Hey, my mathematicians, this is Mrs. Morgan. So remember, this is the problem that I gave you in class today. So take out your notebook and look at your work and then compare it to my work and explanation. So I'm going to quickly review this. Franklin has 5 red marbles, 16 black marbles, 3 green miniature balls, and 9 yellow miniature balls in a jar at his house. What is the ratio of the number of miniature balls to the number of black marbles in the jar? The first thing I thought about was, what is a ratio? Okay, here's a reminder. A ratio is a comparison or relationship between two values or quantities. So, what we want to do is annotate the problem. So, it says, what is a ratio of the number of miniature balls to the number of black marbles in the jar? So let's be reminded that the description of the ratio is important because it gives you the order of that ratio. So it's the number of miniature balls to the number of black marbles in the jar. Now, when we think about ratio, there's many different ways we can represent a ratio, some of which are using the colon, the fraction bar, or even the word to, which you see I circled right here. So now, when you read the sentence, what is the number of miniature balls to, the order, who did they mention first? Miniature balls. So you have to be very careful. Let's not forget anything. I'm going to label my work miniature balls. So I know we're talking about miniature balls. And then it says to the number of black marbles. So I'm going to put black marbles. Well, let's go back to the problem. So, since I need the miniature balls, when I read the problem, I see that they have 3 green miniature balls and 9 yellow miniature balls. So 3 green and 9 yellow. Now I know they didn't specify which type of miniature ball. They said miniature balls. So that means that I have to make sure that I get the total amount of miniature balls, which means I will add the 3 plus the 9 to give me 12 total miniature balls. Now let's get down here to where they're talking about black marbles. Well, I see that they mentioned 5 red marbles and 16 black marbles. But when they said black marbles, I'm only focused on the 16 black marbles. So I'm going to write 16 black. And I know that that is what I need. So yes, they have 5 red marbles in the problem. But looking at the word choice here, the red marbles are not going to be of importance to us. So let's go back to our ratio representation. So when I look at these and I look at the choices, I see that my ratios are presented using a colon. So that means I'm just going to use the colon to represent my ratio. I'm going to put the colon where I see the word to. So the number of miniature balls was 12. The number of black marbles was 16. So I know I should have a ratio of 12 to 16. None of my choices have that. But remember, we learned this in class. We can write equivalent ratios. So we can simplify this ratio. So in order to simplify a ratio, we must use or find the GCF of both the numerator and denominator. And I say that because this can also be written as 12 over 16, your numerator and denominator, or we can also write it as 12 to 16. It can be represented in both ways. So now let's focus back on this. That means I have to find the GCF. Do you remember what that is? I hope so. It's the greatest common factor. So, greatest common factor. I need to find the greatest common factor of what two numbers? 12 and 16. Let's do 12 first. So the factors of 12, I'm going to start with the number 1. 1 pairs with 12. The next number after 1 is 2. Does 2 divide evenly into 12? Yes, it does. 12 pairs with 6. After 2 comes 3. Does 3 divide evenly into 12? Absolutely, 4 times, so the factor pairs 3 and 4. Now, after 3 comes the number 4, but I already have a number 4 here, which means I listed all of my factors of 12. Now let's do 16. I hope this is jogging your memory. So I'm going to start with 1. 1 times 16 gives me 16. Now the next number after 1 is 2. Does 2 divide evenly into 16? Yes, it does, 8 times. So 2 times 8 is 16. The next number after 2 is 3. Does 3 divide evenly into 16? Absolutely not. I'm going to cross it out. After 3 comes 4. Does 4 divide evenly into 16? Absolutely, 4 times. And because I already listed that 4 and it was repeating, I know I listed all the factors of 16. So let's write the factors of 12 and write the factors of 16. So 12, I would get 1, 2, 3, 4, 6, and 12. And for 16, I have 1, 2, 4. I have a 4 again, so I don't need to write it. 8 and 16. Now remember, we're saying the greatest common factor. So first, let's find the numbers that they have in common. I see that they have a 1, a 2, and a 4. Now, who's the greatest that they have in common? The number 4. That means I'm going to come back here and I'm going to divide the 12 and the 16 by 4. So I'm going to say divide by 4 and divide by 4. I'm going to bring down my semicolon. 12 divided by 4 is 3. And 16 divided by 4 is 4. So your ratio, ladies and gentlemen, is 3 to 4. So your answer would be choice B. And before I end this, I just want to point out to you that they will give you a distracted answer. And you know why they have that there? Because remember, one of the first things I said is that the ratio is a comparison of two values, and the description, the order of the description is very important. So if you would have put 16 to 12, you would have gotten 4 to 3. I hope this helped. Please make sure you use this to review your work, and have a good night. The reason that I showed this video was to show you that it is possible to do a spiral review during class time without taking away time from your current lesson. So this took approximately 5 to 7 minutes, give or take. I also wanted to show you that you can also do a recording. And the reason the recording could come into play is just in case a student was absent where you gave this as an in-class problem. Or if you give this as an exit ticket, a spiral exit ticket, most of the time we don't have time to review that work of the exit ticket. We look at it to see where students may be having problems, but we don't have the time to go over that work. So I think this would be important if students engage in a problem similar to this as an exit ticket and submit it before class is over. And then you can upload this video recording to your classroom platform for students to review it and check for themselves whether their thought process was correct. And before doing this, I had to point out the things that I know students needed to know. They needed to know the definition of a ratio, and the importance of the order within the description of a ratio, which I pointed out, different ways to write a ratio. I also wanted to ensure that I annotated the problem. I wanted to show my work using labels and organization. I wanted to purposely think out loud my thought process. I also knew in this problem we're simplifying fractions using the GCF to find equivalent ratios. So I know I had to go over finding the GCF. And then I wanted to point out the distracted answer due to students switching up the order of the ratio description. I hope this was helpful. Bye.